So all right, so the homework for last week was really to get Link moving in kind of a realistic fashion. Well, realistic meaning like relative to the game. So you would have like something like this where Link can move left, right, up, down, and every direction, every time he turns directions, he changes how he's animating. So like I'm turning left, I'm going right, left, up, down, and so he looks like he's moving up and down. The crosshair here, this thing was part of the lab. I can go over how to do this as well. I will do the link portion first, however, so everyone gets an idea of how that works. Okay. What I'm going to do I'm going to start with like a blank project because I think that it's important to go over the steps of how to get Link to animate. Start with the circle here. So, Animating Link, you guys had a lab, a homework where it was you need to animate an explosion, and I went over how to have the explosion be animated. So this concept here is going to be applied for Animating Link too. So Link, if I look at the sprite sheet here, this thing right here has all the sprites that you need in order to animate Link appropriately. He has a lot more than what you need as well. But if you look here, you can see that he has a row for moving downwards, a row for looking up, one for looking left, and one for looking right. He also has a bunch for swinging his sword in different directions, as well as some other animations like when he is playing the ocarina, or riding a horse, or swinging his master sword. So what we're going to do is we are going to have Link animate by having him go through all of these frames of animation for a particular row, and then switching the row that he's on based on the direction that you pushed. Okay. So every time you push a direction, you're effectively going to change the row that you're going to animate Link from, and then you're just going to be continually animating Link through all of these. Okay. That's the general idea. We're only going to use these top 4 rows. Any questions on that? Okay. So first things first, we have to get Link in the game and drawn as a sprite. So as I mentioned before, there's always two parts to drawing sprites in SFML. You have a texture which represents the file, and you have a sprite which represents what the image looks like in your game. Okay. So you point it to the file name, which is zelda.png, which is actually kind of funny because Zelda's not in here. Which I heard, by the way, Breath of the Wild is like really good. Like I'm hearing good things about that game. It's supposed to be really good. So I'm just setting up my sprite and my texture. And what I'm going to do is I'm going to draw this sprite just wholesale onto the screen. So I just want to draw this entire sprite sheet on screen and see that it's working. So there's my sprite sheet. You guys can see it basically is representing the whole thing. This is the actual scale of the sprites. It's kind of tiny. So what I want to do though is I really want to just draw the portion that is one sprite's worth. And so the sprites here, you can kind of see like how big they are. There's a lot of ways you can tell like how big each sprite sheet is. What I'd like to do is I usually like to open up Photoshop here. There's a couple ways you can do this. You can literally just draw a rectangle around the. There we go. You can literally just draw a rectangle around the sprite as you think it looks. You can also specify a grid dimensions so you can see how the grid looks, and you can change the size of the grid to try to accommodate each sprite. So I'll show you both. Right, so there's a Link. So you can see I have a this and I can draw this box around it with what I think is kind of representative of the sprite. Something like that. That might be too big, that might be too small. There's probably better ways to do this, but like I like to open up the info pane and then see here when I draw this thing. See how that has a width and a height here? You can change this thing to be pixels. So it looks like it's 40 pixels width and height. It's a little tiny text here in the info pane, you can see. So you can also get a grid in here. So I have this grid that I can draw, and I can change my, I'm sure there's better ways to do this, but this is the way that I know. So I like to say, okay, show me a grid every 40 pixels. So it's going to literally draw me a grid, and then show me some subdivisions here based on that. So you guys can see a little bit about when I do 40 pixel wide grids, where those grid lines are showing up. Right? If I can color them differently, which I can. You guys can see the blue solid lines are basically every 40 pixels, and it looks like a pretty close approximation of it. And so that kind of covers like even these cases where Link is swinging his sword here. So here, let's see. That kind of covers that. So we're going to use 40 by 40 as our texture width. And now, a lot of times, if you ever want to do this stuff at home and you want to like download a sprite sheet or something like that, a lot of times you'll find sprite sheets that aren't like uniformly spread out like that. For instance, if I just Google like Link sprite sheet, so you get a lot of times stuff that looks kind of like this, which has like no, it's just literally like no uniformity at all. It's even just there. Yeah, it's just, they're just kind of slapped in there. Sometimes you get stuff like this, which is a little nicer. Sometimes you get stuff like this that looks at first like it's correct, but a lot of times it's not. Like some of these like aren't actually ready for animation. So like I don't know why they do this. I don't know why they make a sprite sheet but then have things like this, like where these things are like not spread apart evenly. So something to keep in mind. A lot of times you'll have to do fix up, like you'll have to take this thing and actually move it to be within a grid. But I was able to find something that actually works pretty well for us without too much editing. So, okay, so it's 40 by 40. We're going to use that as our unit of measurement here. Close this guy, close this guy. So we're going to create a rectangle that is 40 by 40. So it's going to start at 0, 0 and be 40 by 40. And that's what we're going to draw on the screen. So there he is. Cool. Super tiny. Let's scale him up a little bit. Let's scale him up to be 4x. That looks a little better. So we're going to use the same concept that we did for explosion, where we're going to have the concept of sprite size. I use that here and here. And I'm going to use row and columns as well to indicate where I want this rectangle to be. Like so. The reason I do this again is so that if I wanted to say pick like column 4, row 6, I can pick whatever sprite is there by just changing those two numbers. And then all I have to do is really change those values over time, so it'll cause it to animate. Okay. So if I start off the row at 0 and the column at 0, what I want to do is I actually want to move this set texture rectangle to be inside my loop here, right before I draw the sprite. I can actually do it like right here or right here, it doesn't really matter. And I'm going to set up a timing event so that I can animate this thing over, just exactly like the explosion. I'm going to set it up so it animates the entire row. To that, I'm going to create a clock for myself, and I'm going to create a time based on restarting the clock every time I go through this loop. Every time I go through the loops, I'm going to restart the clock, and it's going to tell me how much time has passed. And then what I'm going to do is, if I need to keep track of how much time has passed because I want to know how long I'm going to spend on a single animation frame. So I want to keep track of my current time. It's going to start at 0. And what I'm going to do is I'm going to accumulate this current time based on my delta time. So I'm going to add my delta time, which is represented in seconds, into my current time. This is exactly what we did for explosion. And then if my current time is greater than, let's say, 0.05, I don't know, I'm trying that, we can kind of pick how fast we want Link to animate. And this is something we can play with as we run this over and over again. We're going to take our column and we're going to add 1 to it. And if our column is greater than however many sprites are here in our sprite sheet, so 1, 2, 3, 4, 5, 6, 7, 8, 0, 1, 2, 3, we're going to reset our column back to 0. What's interesting here is that what we actually probably should be doing, and I'll show you guys this next, is Link should really be starting at column 1 instead of column 0, because 0 is actually his idle pose here, in this case here. It's not always the case for all these, but like in this case here, that's his idle pose facing up, and he has an idle pose facing left. However, he doesn't really have an idle pose facing right, which is funny about this sprite sheet, so it's over here. But we'll try this. So let's try this. We're going to update the column every 0.05 seconds. And we're done.
Finish up. Enemies quit.
So you guys know what's actually happening here? It's a bug. Can anyone spot and tell me what is actually happening that I didn't do, that I need to do?
It should be row instead of column.
It's not, but I'll show you what happens. This columns for sure. Can anyone spot the bug? It's a very common bug. I literally just did it.
Is it with how fast it's going, or?
It's not fixing it.
It's going to completely different sprites on the sheet, so probably something that has to do with the values of row and or column.
Okay. Anyone else have an idea on what where the bug might be? You're on the right track. Something related to time.
Should it be row?
Nope. I'll give you guys a hint. So I have my current time. He's keeping track of how much time has passed. After enough time has passed, I'm going to move my column by 1. Then, the next time through the loop, I check to see how much time has passed again. However, what's happening to this value here is I'm adding to it every frame, right? So it starts off at 0, goes up to 0.5, and I'm not resetting it back to 0. Which means that this number here starts at 0 and starts going up and never stops going up. Like it will always be greater than 0.05. So I need to do this. I need to reset it back to 0. Because if I don't, then it just will animate as fast as it wants. Now that's looking a little bit more reasonable.
Still doing the windmill thing.
Yeah, he's doing the windmill thing. Because I messed these up too.
Okay, so I was right in a sense.
You weren't right for the right reason, though. That's the important part for that bug.
Darn it.
So it's also showing Epona for a frame, so we're changing that.
But we love Epona.
Cool. So now Link is animating. If I wanted him to animate going up, I just have to change my row here. I change it from 0 to 1. Now he's moving up. Cool. And if I want him moving left, I change this to 2. And if I want him moving right, I change it to 3. So you guys see what I'm doing? I'm just changing that row number, and it changes the direction that he's going. So if I know that, then all I really have to do is when I press my keyboard, I need to just change the row that he's on. So what I can do is, if this, I'm going to use the polling method here because I eventually want this thing to move as well. If is key pressed, I'm going to use up. I'm going to set the row equal to 0. I'm sorry, row equal to 1 because that's up. Then I'm going to do this 3 more times. 1 for each key. And I'm actually not going to put else if here because I want you to be able to press multiple keys at the same time. So you can move diagonally. Down will be 0, left will be 2, and right will be 3. So all I'm doing is I'm just setting the row when I press a key. So every time I press a key, I'm going to change a row that I'm animating. I'm not moving or anything like that. So does that make sense? Just changing a row? Because the row is really what dictates which animation I'm changing. So every time I press a key, I'm going to do that. That's how I get him to face the right direction. The next step is to get him to actually move. So moving objects is something that we did in lab, which is in order to move something, you just have to move it based on, there's a function you call called move, and you give it a direction in x and y and how much you want it to move. So what I'm going to do is I'm going to have the link sprite here move. When I press up, you're going to specify an x and a y. So here I'm going to just do, this is going to be the amount that you want it to move every frame. If I put in a number like -10 or something like that, that's a really fast movement for a link. That means that he's going to move 10 pixels every frame, while as long as you have that thing pressed. So it's really fast. So I'm going to shrink that thing down to something more reasonable and small. Now he's moving a little bit slower. Cool.
Stop reading all those.
However, remember I talked about how the amount that you move is based on the speed of your computer. So in this case here, this 0.01 changes how fast he moves based on how many times this loop runs. So if I want to move a consistent rate, no matter what computer I need to use this delta time. So what I'm going to do is I want Link to move, I don't know, 50 pixels per second. In order to have me move 50 pixels per second on any machine, I take this concept of how much time has passed and I incorporate that into my movement. So when I'm moving here, this will be -50, I'm going to move 50 pixels per second whenever I'm holding down the key. So up and down will move at a consistent rate here. And up will move at a consistent rate this way. Same with left and right. The difference is that left and right move you in X. Like so. And you can increase the speed. Maybe you should move a little bit faster here. And that speed here, he'll move that speed no matter what computer he's on. Okay. And that's it. That's how you get Link to move.
It's like he's running backwards there.
Yeah, seriously.
It does look like he's running backwards.
Yeah, when he's going right.
What's that?
When he's going right, it looks like he's walking backwards.
There was a problem with this way that I'm doing it, and this is kind of a problem that's more something we'll solve in asteroids. If I'm moving right, how many pixels per second am I moving? What is it? 150 pixels per second, right?
Yeah.
Moving left, I'm moving 150 pixels per second. Move up, I move 150 pixels per second. What if I'm moving in both directions at the same time?
You
How fa-
done twice that?
It's not twice that. It's, you know, the Pythagorean theorem.
Oh.
If I move 150 this way, and I'm moving 150 this way, what is this? What is this? You guys, does anyone remember?
Plus b squared.
Yes, a squared plus b, this is b squared equals c squared. So how fast is this actually? If I say I'm moving 150, that's 150 plus 22500. Take the square root of that.
Yeah.
212 pixels per second. He's actually moving faster when he's moving diagonally here.
Shortcut.
You guys can actually see that. You can tell. I'm moving this way, and I'm faster.
Damn it.
So this is something we'll solve. Well, we would normally solve for asteroids. And the way you do that is you take the direction you want to move first, you figure that out, and then you move exactly 150 pixels in that direction by using this formula, a squared plus b squared equals c squared. So if you solve for c here, it's the square root a squared plus b squared. Right? That's how you get c. Okay. So we'll get more into that.
Yeah.
So that's how you do link. Any questions on that? If you want Link to do some of his other actions, like let's say you wanted him to do an attack and stuff when you press spacebar, you can do that. It's a little different though because you want him to swing in a direction. A lot of times you don't want him to like be able to move while he's swinging. So these are interesting problems that introduce some complexity into the game, but I think are kind of a fun thing to try and solve, where trying to make spacebar have him do an attack means that you kind of need to prevent him from moving. You guys remember how I asked you guys to hide the rectangle last week? Yeah, hopefully you guys remember it very fondly. How you keep track of whether or not you should be drawing the rectangle? Well, that very simple kind of concept of using a variable is what's applied to make Link also not be able to move when he's attacking. So it's something that is a kind of a fun exercise for you guys to do. Let me do the crosshair next, because I think the crosshair is like the last part. So in the lab, let's go over that. This is the lab from last week. In this case here, I asked you guys to change a rectangle to use the crosshair. You can basically make it so that you have a shape that follows the position of the mouse. And so the previous lab was asking for getting the position of the mouse and moving a rectangle to where the mouse is, so we can do that. If I just go to my engine here and I just make a rectangle, and I'm going to make this thing, I don't know, 0, 0, 40. That's right. I specify the size. And then what I can do is I can draw this rectangle. I need to set the color and everything. Here's my little rectangle here. And I wanted you guys to just move it to where the mouse was. So you can call set position here. And you can ask the mouse. In the lab, I printed out, hey, you can get the position of the mouse by calling this here. And you can store it into a variable called mouse position. And if you pass in the window, it'll get you the mouse position relative to the window, as opposed to relative to your monitor, which is not what you want. So if you do this, if you set the mouse, if you set the rectangle to be the position of the mouse, it will move wherever your mouse is relative in the window. So there's my mouse cursor here. I can get it so that it draws in the middle as well. As I mentioned here, you can set it to the origin. But first, let me actually use the texture that I want, the crosshair texture. So same thing with Link. What did I call this thing? Crosshair.png, I believe. Yeah. Okay. So I don't really get the why they did this, but in this case here, a rectangle, if you ever wonder how to set the texture on a rectangle shape, it takes a pointer to a texture, which is the memory address of where the texture is, so that's why you need to put an ampersand here. But it's different than how you set the texture on a sprite, so keep in mind that difference, that when you're setting textures on a rectangle, you need to pass in the address of that texture. My little guy, my little crosshair. I can make this rectangle bigger. Bigger crosshair. And then I can also set the origin of this thing so that it's in the middle of my mouse cursor. Like so. And then finally I ask you to use the mouse wheel events so that you can make this thing go bigger and smaller. So there is an event, mouse wheel scroll delta, that contains how much you scroll the mouse wheel. And you can use that to actually figure out how much you want to scale the mouse cursor. So an event means that you have to put it inside the event loop. There's my mouse wheel scrolled event. So now I'll only care about events in this if statement for things that are considered mouse wheel scrolls. And I can print this out to the screen just to prove on the console that I'm getting these events when I scroll my mouse up or down. You guys can see in the top left there, scrolling. So whenever you get this, you can also inspect the event to identify how much you moved it. This event mouse wheel scroll delta contains how much you scrolled the mouse wheel. So if we print that out as well, delta. This is a float, so I'm going to print as a float. You guys can see -1, +1. Sometimes 2 or 3, based on how fast I spin it. So I got a 5 there. Basically, the harder you spin it, or if you have one of those mouse that's like a free scrolling mouse, sometimes you can get more or less values. So I can use that information now to scale my sprite. So the way the scaling works is you can set the scale directly. That is, you can say exactly blow away what the scale is, or you can tell it to scale on top of what it actually already is. So you can say scale an additional amount, or set the scale directly. So in this case here, if I say set the scale every time I scroll the mouse to be like 1.1, that'll scale the mouse cursor 10% every time I scroll the mouse, no matter what. It's growing 10% at a time. Okay. If I do a smaller number, like 0.9, that'll reduce the size of the mouse cursor by 10% every time I scroll. Okay. So using that information, all I really have to do is figure out whether I should be using 1.1 or 0.9. What I can do is I can actually just add the mouse wheel delta here and scale that by some amount. So if I take this mouse wheel delta and I don't know, take 0.01 times it, so I'm going to take my value of 1 or up to 5 and multiply it by this number, I can appropriately increase or decrease the scale based on the mouse delta. So I'm just adding the delta that I print out to the screen, multiplying it by 0.01, and I'm getting this number on the left here, like 2. I'm taking that, multiplying it by 0.01, and then adding it to 1 to get my scale. You can make it scale more or less based on how big this number is. So if you want to scale more every time you scroll the mouse, you can just increase that value. That value is basically how fast you scale. Right. And that's how you get the mouse wheel. it is important to remember that this is an event, so you have to put this inside this event loop. There's a second while loop here, the poll event loop, and you should put a condition here on when you want to handle that event. All right, any questions? All right.